Okay, so thank you everyone for joining us today for our webinar entitled Creating a Country Mosaic with RapidEye Imagery and GXL. We have the pleasure of having three wonderful presenters today. The three presenters include Andre Castillo, is from Blackbridge, which is a Planet Labs company. Andres is the regional manager for Latin America. We also have Rainier Ressel from Canabio and Florian Hruby from Canabio. Both of these gentlemen are with an organization that is responsible for environmental management, environmental monitoring, and they have been leading efforts within Mexico to make use of satellite remote sensing as a technique to collect information as to biodiversity and to help in policy making across government agencies. So we're very excited to hear about how this organization has used remote sensing on a large scale, so on a countrywide scale, RapidEye imagery in particular, to collect imagery and monitor conditions across time. So my name is Kevin, and I'm your host today. Essentially what we do here at PCI Geomatics is we produce image processing software, and the software that we produced is flexible and scalable. We have here an example of the offerings that we make available through our software offerings. We offer a desktop image processing package, which is known as Geomatica. This is a software package that can be used to do orthomosaicing on smaller scale projects, so maybe tens of images or hundreds of images. And then on the other end, we also have scalable high volume production systems, which is what was used in this project in particular with Canabio. It is a system that can do parallel processing and can do massive production of imagery, correction of imagery, mosaicing of imagery, and different operations on imagery. So it's known as GXL, and it really allows customers and different organizations to take thousands of images, tens of thousands of images, as you'll see in today's example from Canabio, many images to produce different types of products, in this case a single country mosaic made up of tens of thousands of images. In the middle we have a lot of possibility. The reason we put this Python icon between both Geomatica and GXL is our software is extensible and flexible. So we have Python API that can be used to extend capability both for Geomatica and GXL, and we think this is a great option for processing different types of projects. Now, in terms of production capability, we can deploy the technology in different ways. On the left, we see a typical deployment of a GXL system where perhaps we have fewer operators and we leverage more automation where we can process in parallel different types of different images and do large processing using parallel processing on a larger system. Of course, we can also achieve large volume processing with Geomatica by deploying more licenses and using staff to do processing of large projects. That's also a possibility. We tend to see more detailed research and analysis being done with our desktop image processing software, and then that operational research or that operational production methodology then gets deployed on a massive scale with our GXL technology. The technology can be used to develop custom workflows. So here we have a workflow that combines Geomatica for extracting elevation models from stereo imagery and using volume calculation within ArcGIS. So this is just an example of a custom workflow development. In the case of Canabio, you'll see that they used GXL to automate the production and iterate through multiple instances of the production to generate the country mosaic, tweak some parameters, and achieve a result that is up to the quality standard that they wish to achieve. So at this point in the presentation, I'm going to hand over to Andreas and let him tell us about Blackbridge. So Andreas, I'll pass you control.
About the images that were used for building the mosaic. As a matter of introduction, our company is Blackbridge, a Planet Labs company, as you may have here in the news. In the last months, our company was acquired by Planet Labs, which is a Californian company with the vision of being able to take a satellite image of the landmass of the Earth every single day. However, in this webinar, we are going to focus in our actual constellation, which is the RapidEye constellation that is collecting more than 5 million square kilometers per day and collecting the images that were used for the mosaic that Conavio built for Mexico. Let me share a bit about our constellation and our position in Mexico. We are a company represented in Mexico with a distributor called BITS that maybe most of you know. And these are the characteristics or the main characteristic of our images. We have images with a 5-meter resolution, with a broad array collection. We have 5 spectral bands, which include the red edge band, which is very important for forestry and agriculture, or projects that Conavio do in Mexico. But however, I would like to focus on the characteristics that are most for the production of the mosaic. I already talked a little bit about the spectral resolution. We have red edge and near infrared, useful for agriculture and forests. 5-meter resolution, good enough to see how the landscape is and execute analysis in the forestry and regional management environments. But for us, the first key, or the key characteristic of our constellation that allow Conavio build their products is a high collection capability. This map shows how many images have been we able to collect with less than 20% of cover on 2014 in Mexico. So as you can see, we have a complete coverage of the country. But we collect and keep collecting all over Mexico. And also we have images collected in 2015, almost in the same frequency. So as you can see, we do not only have one version of the country, but we have collected several images of the complete country. So the high availability of our images is the key asset from our side in order to build this kind of products. The second main characteristic is the accuracy, and this has been a long journey for us. We started the production of our products in 2016 using Landsat ground control points, but definitely that was not the best way to do it. So we have improved the quality of our ground control points, and now the images that we can deliver, or actually the images that we deliver to Mexico, are always under 10 meters RMS error, which is by far the best absolute localization error that you can find in products of this resolution. So this is the second important characteristic of our images in order to help the mosaic of Mexico. And third, the licensing is also a key characteristics. We have delivered our images to the government of Mexico with an all-gov license. That means that every government agency in the Mexican government can access the products that are delivered and also the images that has been delivered to Conavio to build this project. So this is also a key characteristic of our solution. We have built mosaics in several parts of the world, or our customers have built mosaics in several parts of the world. This map just shows one of our latest mosaics. And as takeaways, I will tell you that RapidEye Imagery is great for large area mapping for building mosaics, especially because our positional accuracy, our large collection capability, and also because of the licensings that allow to share the information between several users. So this is the history from our side. So I think, Rainer, are you going to continue?
I just have one quick question, Andres. If you can comment on the use of GXL at Blackbridge. I understand that GXL is used within your organization as well.
Yes, we have been partners with PCI for a long time. PCI is the platform that we use to produce internally and externally our products, including the mosaics. And the map that you see here, the map that shows all the mosaics that we have delivered externally, built internally, all of those products has been using PCI.
Great, thank you. So at this point, we'll ask Rainier and Florian to give us an overview on Conabio.
All right. Well, thanks, Kevin, and thanks, Andres, for giving that introduction about some of the technical requirements of the data which we received here in Conabio. My name is Rainer Ressel. I'm the General Director of Geomatics in Conabio. And before Florian goes into some of the actual work we were doing on the mosaic, I would like to give a few slides only on an overview about why we were doing that within Conabio and some general information about Conabio itself. Conabio is our National Commission for the Knowledge and Use of Biodiversity. It's basically pre-headed by more than 10 different ministries within Mexico, and our main responsibility is to promote and coordinate any actions which are related to biodiversity related information in the country, which means we are obtaining and organizing and analyzing all different information which is related to biodiversity and make this information accessible to the government, but also to the general public in general terms. We understand ourselves a little bit as a bridging institution between academia and the government and the civil society in general, which means we are not directly an academic institution, but rather part of the Ministry of Environment, and we are trying to provide useful information for the decision makers, in that case in particular the Ministry of Environment, and in that frame we also have to see the creation of this mosaic, which I will explain a little bit more later on. Our geomatics division currently has around 50 employees, mainly biologists and geographers. And we started basically with all activities here using remote sensing data with our own NOAA AVHR station in 1998. The AVHR station was acquired in 2000, and after that, as it was quite successful, we were also using our own direct readout station for receiving MODIS and VIRS, which is running now since almost 15 years. And we are basically using the information we are gathering and from our own stations, but also from other satellites such as RapidEye for different applications. One of the most important applications is near real-time fire monitoring, which we are doing operationally since the year 2000. We are generating a variety of operational terrestrial products which we are providing to our customers, free of charge, of course, which, for example, is land surface temperature or vegetation index. And we are, besides of the terrestrial part, we are also looking into ocean monitoring, and we are providing geo and biophysical parameters such as CCT and chlorophyll. And our main task is trying to provide information on a national scale. That's why we are doing a lot of countrywide ecosystem studies, such as the mangrove inventory, which we are currently finishing also for 2015. And we are looking into a lot of land cover studies where we are also using the RapidEye data which we obtained since 2011. Well, just for the history, Conabio generated its first satellite mosaic in the year 2000 using our own AVHR data. And right after that, because we had a pretty good impact in the country using that type of information, we also tried to compile the first satellite mosaic in 250-meter resolution using our own data from our own receiving station in the year 2002. Just to put that in the context, that was long before Google Earth actually was online, and we're providing a 250-meter resolution at that time in 2002 was still quite a challenge computational-wise. And because of that, we are thinking we are having a certain interest in doing that and continue our efforts in providing that type of information. We were deciding also to do something similar using RapidEye data for the entire country in 5-meter resolution, and for that we were using basically all the information available, which Florian shows in a minute, between 2011 and 2015, and we started with that basically in late 2013, but in particular we were actually working on that almost the complete entire last year. Now this was our first mosaic, just to give you an idea. This is what you see today in Google as well. Just to recall, this was done in the year 2002, and at that time it had a major impact on the country, and we hope that we are going to repeat that impact also with the repetition of countrywide mosaic using the 5-meter data. Now, why are we using this data, and why are we generating a countrywide mosaic, in particular in an institution como Conabio? We think it's an important baseline information as it's a reference data set for many different applications, also related to biodiversity studies and general ecosystem monitorings, as we are going to have a good reference data set for the upcoming years. In addition, as we are using a lot of other satellite data, high-resolution data as well, such as, for example, SPOT within the country, we see that this will be a major enhancement in referencing other data sources, as we can generate, for example, an automatic chip database, which will provide tools for georeferencing of this third remote sensing data. And we see that as we are having an own geovisualization sector within Conabio, where we are looking into 3D and 4D animations, we see that high-resolution texture information is very valuable for geovisualization purposes. So that's a major idea where we want to use this data for. And then at the end we see that this type of information is also very valuable for education purposes. We have provided state maps for public schools for the entire country, for all states, using the MODIS mosaic, which I showed before, and now we are trying to do the same with the RapidEye mosaic once it is completely finished. And finally, also important, we simply want to show that Mexico, a Mexican governmental institution, can do it, that we can have the technical capabilities together with a very powerful software such as GXL, and with the help of PCI, that it's possible to do that in a development country such as Mexico and in a governmental institution. So that was also one of the drivers for doing this within Conabio. And we see in general this is useful information as it raises public awareness of the usefulness for the remote sensing data for all different environmental studies, and in our case in particular for biodiversity issues. Okay, because of the time, I think I'm gonna stop here as a quick overview in Conabio, and I would like to hand over to Florian to give us a more technical detail about how we were actually doing the countrywide mosaic.
I will use the next few minutes to give you a quick overview on the creation of a countrywide mosaic by the example of Mexico. The title of our presentation talks about mosaicing. Making mosaics, what do we mean by that? A mosaic is like a puzzle. Small pieces of information are put together in order to create a picture. Here, for example, the picture of this mosaic is Mexico. However, for cartographic concerns, we usually do not aim for a traditional mosaic where you can still see each single piece of information, but we rather are interested in a mosaic like this one, a seamless visualization without any points of ruptures and without clouds. This being said, what can I offer for my presentation? We start with a quick review of the data used in this project. We will see how we filtered a total number of 50,000 scenes in order to obtain a best offset of 4,500 scenes, which are necessary to cover the whole country of Mexico. We will also see which method and which software we use to convert these images into one piece of homogeneous information. And we will close our talk with a quick look on the prototype we have published so far. So basically what we are trying to do is creating a map of Mexico, a map that shows the whole country in a uniform resolution, and we try doing this using satellite imagery. Concretely, we are using RapidEye data. You can see here an example from La Paz, located in the state of Baja California. These images have a resolution of 5 meters. Andres already mentioned this. So we don't use the highest resolution data available today in the market, but let's zoom to the full resolution. Anyway, we are at a very high level of detail, so we can distinguish, for example, different vegetation elements, including single trees. Having a resolution of 5 meters, each pixel, a RapidEye scene has 5,000 times 5,000 pixels. So each scene covers an area of 25 square kilometers. Now being Mexico number 13 in the list of the world's largest countries, we have almost 2 million square kilometers to cover. So we need approximately 4,500 scenes. Now maybe you would ask, we have Esri, we have Google. Why do you want to make your own mosaic? Let's have a quick look at Google. In Google, at first view, the mosaic looks perfect. No cloud, no point of rupture. It's impeccable. Let's zoom a bit. For example, here on the Pacific coast of Mexico, still perfect. But if we even zoom a bit more, let's say on this little bay here, so here you can see already a number of imperfections. Clouds cover the ground. We have radiometric differences. You can clearly see the cut lines between neighbor scenes. So that's no longer the seamless and cloudless visualization we are interested in. Naturally, if Google has this kind of problems, it can't be a trivial thing. And indeed, if you load a few scenes into any common geographic information system, we get the same result. Many clouds, cut lines, radiometric differences. So building a mosaic is not an easy matter, especially if you take into consideration the volume of data we have to process. In the case of Mexico, especially, we need 4,500 scenes. That's more than 1 terabyte of data. This results in a single image file of 800,000 times 450,000 pixels. And that's not all, because we have RapidEye data available for the years 2011 to 2014. So that makes a total of 50,000 scenes to work on. Against this background, And against this amount of data, we can define three important criteria that have to be met. Firstly, the hardware, secondly, the software, and thirdly, we need a method. Regarding the hardware, I won't go into further detail here, just mentioning that Konabi has a computer cluster with sufficient power to handle terabytes of data. So I'd rather focus on the software and on the method we applied. Before that, a few words on the data. We said it needs about 4,500 RapidEye scenes to cover Mexico. You can see here the relevant scenes. But we also mentioned that we have a total of 50,000 images for the last 4 years. So the first step, we needed to select the best 4,500 scenes in order to start the mosaicing process. What do we mean when we say best scenes? Best includes basically two aspects. Firstly, we are looking for images of the same time of the year to avoid that the natural vegetation changes during the different seasons of a year affect the combination of scenes. And secondly, we are looking for the scenes with the least cloud coverage available. In order to facilitate the pre-selection of our best scenes, we excluded all rainy seasons because rainy season images generally have a higher probability of cloud coverage. So after this pre-selection, about 25,000 dry season images remained. Of course, this still is quite a lot to make a manual selection, so we took advantage of the metadata that includes information on date and cloud coverage for each scene. So we used a small Python script. Actually, the guys from PCI provided us with the script. And the script allows for filtering automatically the available scenes based on the criteria of time and cloud coverage. So we applied the script on our 25,000 dry season images to obtain our best offset of 4,500 scenes. Now that we have defined the best of data set that we will use to generate the mosaic, we have to solve two basic issues. Actually, I would say that these are the two main issues of each mosaicing process. Let's have a look at this example, again of La Paz. We have 4 scenes taken almost on the same day. It's the last day of February and the 1st of March of 2014. The scenes are completely cloudless, so we have perfect conditions. But anyway, you can clearly see the cut lines between these scenes. So the first of the two basic issues of mosaicing I mentioned, you have to adapt the cut lines of each scene to the topographic situation in place. Here, for instance, you can easily see the straight vertical cut line of the original scene, and it would much less perceivable if the cut line could follow, for example, this highway or the margins of these fields. So the first basic issue of mosaicing is cut line optimization. And the second basic issue of mosaicing is color balancing. That is, you have to try to minimize radiometric differences between neighbor scenes. So having these two basic issues in mind, we started to use PCI technology, concretely the geomatching accelerator, GXL. GXL comes along with a series of different algorithms on cut line calculation and color balancing. I just want to briefly describe the algorithm we used for our Mexico mosaic because it's a new feature, or it was a new feature in the 2015 release. Most common color balancing algorithms calculate one set of coefficients for each image. The special thing about the new algorithm we used is that it calculates up to 4 sets of coefficients for each scene. That is one set for each margin between neighbor scenes. So the coefficients are being calculated for each margin and for each band of each scene, both regarding gain and bias. That means regarding contrast and brightness, showing this result. So it's you get a seamless visualization where you no longer can distinguish between individual scenes. Maybe once again. So we use the so-called bundle algorithm. And if we return with this algorithm to our example site of La Paz, and if we apply both the bundle color balancing and an automated cut line optimization, we get this result, which is a significant improvement. Here you no longer can see, once again, here you no longer can see the individual scenes, but just one seamless visualization. And that's exactly what we want, and we want it for the whole country of Mexico. So this is this process of color balancing and cut line optimization was done in GXL. Let's have a quick look at the GXL interface. GXL has been installed on one of our servers, so I can access it using any web server. Let's have a look at one mosaic generation job. So you see it's a web interface, quite straightforward. You define the input directory. In our case, that's the directory of our 4,500 best of scenes. And here you can choose between different color balancing methods. In our case, we took the bundle algorithm. And likewise, you can choose between different cut line methods. So you decide how to do the cut line optimizations and how to do the color balancing here. So the result of this process in GXL is a basic version of the Mosaic. On this basic version of the Mosaic, you can run a series of post-processing tools to enhance and polish the product. Actually, we are currently in this process of polishing, so I'll just mention one tool, which is part of PCI's Geomatica software package. As I mentioned at the beginning, we want a Mosaic that's not just seamless, but also cloudless. Here in Mexico, we have several tropical regions that show a certain amount of cloud coverage during the whole year. And especially for such cases, Geomatica provides a tool called Smart Geofill, which proves particularly useful. Basically, the Smart Geofill tool allows to subsequently adding scenes for a mosaic already generated. So let's think, for example, here we have our best of scene with a cloud coverage of 2%. So as this is the best scene available, we will use it for the mosaic preparation project for the first version of the mosaic. Now I have here this little cloud disturbing my mosaic. So let us further imagine that I have a second scene for the same place with cloud coverage of 30%, but just where this little cloud is disturbing my best scene, the second best scene with 30% cloud coverage is completely cloudless here. So it would be great if I could just copy this part of the second scene, copy this part and paste it here. And that's exactly what the Smart Geofill tool allows me to do. You see here an example with real data. I have this cloud and the according shadow. So using the Smart Geofill, I define the area I'd like to replace, look for another scene of the same place where this part is cloudless, and I paste it on over the cloud. This is done, once again, this is done in a way that fades the new data, so you won't see any cut lines afterwards. To sum up the mosaicing process so far, so in the first step we use GXL to create a mosaic based on complete scenes, a kind of macro mosaic. And in the second step, for the most problematic scenes, that is for the most cloudiest scenes, we create mosaics based on little pieces of scenes, a kind of micro mosaics using the Smart Geofill tool. As I said, we are currently in the polishing part, working on details like clouds or saturation enhancement. However, even the results achieved so far show some significant improvements compared, for example, with a mosaic provided by Google. Here we are in the southern part of Mexico, in the state of Chiapas. Google Map Google Maps, we see the coordinate scene here, comes along with several clouds. You can also see some cut lines and other imperfections. If you compare the same place with our RapidEye mosaic prototype, we can see some significant improvements. Let's compare that again. So you see that we can definitely achieve a cloud-free mosaic also for tropical regions. So we're still with the prototype, but once finished this mosaic, this puzzle, what will we use it for? Rainer also summarized the basic objectives we have with this project. So as he said, we will use it basically as a visualization device, for example, a base map for different web mapping applications we provide. For example, in our GeoPortal, we also plan to print a mosaic in different large-scale formats, and we hope to use it also as a baseline information for different environmental studies. As I promised at the beginning, Kevin, you tell me please if we are running out of time.
It's fine.
But as I mentioned at the beginning, we published a prototype version already online. That's the coordinate link here. So it's www.biodiversity.gob.mx/atlas. So let's jump to the online version. Using this URL, you'll enter a site where we offer different atlas-like web mapping services. So you have to choose the option Mexico seen from space. We currently just provide a Spanish version, but it's the first link. So the prototype doesn't show the full resolution. We have downscaled it by a factor of 10, more or less. Let's start maybe northern part of Mexico. That's the borderline between Mexico and the United States. You can clearly see the border because the agricultural structure is quite different between Mexico and the States. So this is Mexicali on the Mexican side and Calexico on the US side. If we move a bit in a southern direction, it's the so-called Laguna Salada, a dry lake. It's about 10 meters below sea level, so it's the lowest point in Mexico. You can see here that we already have a quite decent result from the GXL process. You also see that we have still some details here. Here, for example, you still can see the cut line. So in these cases, we have to do some manual post-processing in Geomatica. You define some so-called dodging points and decide, for example, in this case, I would like the right side to show more contrast. Generally, if we move across the northern part, I hope the transmission of the screen is fast enough. So the northern part of Mexico is already pretty good. Since the climate is a dry one, we don't have a lot of clouds. So the automatic process that we see here gives a almost perfect result. Here it's hardly impossible to see any cut lines. Let's move, for example, to a coastal region. You can see we used for the moment a water mask to exclude all water parts from the mosaic, since the characteristics of water are quite different. So in the coastal area you can still see the size of the original scenes. That's what we want to do in the final process. Work on the coastal areas and also include some bathymetric data to obtain a visualization like we've seen in the MODIS mosaic at the beginning. So we also want to fill up the ocean parts of Mexico. Let's visit, for example, an urban area, just to give you an idea on saturation issues. Let's zoom, for example, on the town of Guadalajara. It's the second largest town in Mexico. It would be here. That would be Lake Chapala. Well, so you can see the result in the case of Guadalajara is also pretty good. I guess it's no longer possible to see any cut lines. Guadalajara is made up of 4 scenes here. I would just like to show one more detail of a tropical region. As we mentioned, this is the most problematic area for each mosaicing project. So let's jump again to Oaxaca. Yeah, so beside the city of Guadalajara, you can see here the Lake of Chapala. That's one of the few sites where I already made some manual post-processing. So the water area usually don't look that homogeneous, as you can see it here. So we have good results also for urban areas. We can get quite good results for water areas using some post-processing. And to close our journey through the mosaic here in the south, so here we're already close to the borderline with Guatemala. If you visit this region, this mountain region in Google, for example, you will find a lot of clouds, because especially these oceanside hill slopes show a kind of cloud coverage during the whole year, actually. But you can see that although there are still some clouds or some kind of haze, like here, you can see it's already a quite nice result. And I guess it's not difficult to imagine that in the end we can obtain a completely cloud-free product, replacing these details, for example, with the Smart Geofill tool. So that's all from my side for the moment. Kevin, if there are any questions regarding the mosaic from your side, please let us know.
Sure. I guess one question that we had was the processing itself. Could you describe the method that was used with the GXL system? Did you run this one time, or did you run this multiple times?
Let's have a look again on the GXL system, on the online interface. We did some kind of iterative process. So here you can see the different color balancing methods and cut line methods available. So we tested the different methods available and compared the results.
And also played with the input images, I guess?
We also tested with the input images, because the script you provided us offered a few options regarding time and cloud coverage. So we tested both options, both the input data, both the methods available. Regarding calculation time, for example, the job I showed is about
So this is for the 4,500 images to do a particular job?
That job was done on the 4,500 images, yes, and it took us about 4 hours, 4 hours, 20 minutes.
I see. So that allows you to easily run it over and over again because it's not very long to run it.
Of course.
Great. Okay. I'll just quickly take control here to sum up. So if you're interested to take a look in a little bit more detail on the Mosaic, Florian was showing us a live preview. I've included the link here on our presentation. Florian also described it. So head over to biodiversidad.gov.mx/atlas and then click on this icon to view that Mosaic preview. Again, as Florian mentioned, that's not a full resolution. I believe it's a 20 meter pixel as opposed to the full 5 meter pixel. And also on PCI's website, we have a section that gives a little bit of an overview on the Canabio case, and you can watch a video that was produced that zooms into the different areas within the Mosaic. As you saw, it's a very diverse biodiversity is very diverse. There's a lot of different landscapes in Mexico, and it's quite a challenge to produce the Mosaic that you saw. So with that, I'd like to thank our presenters and thank you, our audience, for attending today's webinar, and we'll talk to you soon.